one of the two that we have. And then we have this very nice example where we are seeing three examples. The insects walking, kismet behavior, which seems extremely appropriate. And now we are talking about how a dog works, no? With an approach which emerges from a complex dynamic. The principle are, so essentially we have some oscillation on knee joint, and we essentially exploit the morphological computation. This was done by Fumiya Idia, then a student of Rob Pfeiffer at AI Lab in Zurich. And now in Cambridge, we had a guest lecture from him a few weeks ago. And this was a very nice thing. So is it possible to build a puppet walking with essentially almost no control, so very much perfectly in line conceptually with the corner ranger? And now Nathan may show a couple of videos. Yes, it is. So this puppy on the treadmill is actually able to walk, and what it does is it has a super simple control, so just oscillation at the joints at the hip, so a couple of joints. We talked about material, spring-like material properties, so it is elastic, no? It exploits the elastic. It's self-stabilized. Why? Because it has been designed for copying a real puppy, but in such a way that it can self-stabilize. It depends on where it is the center of mass, how you have designed the legs, where are the springs. So this requires significant effort. But luckily we have dogs and we can try to take some inspiration. Fumiya did that, and this is the result. So almost no control, a behavior which is much more natural than the behavior of many other robots' dogs. Maybe we can also see, if you look for a while to the slide you see, no? So you have the only oscillation is the one where you see the arrow, then you have springs in a couple of other joints, but the legs are passive. By the way, this mechanism that you see here with the treadmill, and you see in insect walking, is also called stigmagy, which is the fact that you transmit from leg to leg in some way, in a way that you can make more precise. You transmit information from one to the other. Now, maybe you also have the slow motion video. So if you look at it in slow motion, you see what happens. No? So it's a very chaotic and random behavior, but it is appropriate, and our intuition tells us that it is very... Now I finish because I think I have already taken some minute more than necessary. So more or less what we have seen here is a structure. The structure of puppy is a kind of model architecture where I have the controller in animals, the central nervous system, a musculoskeletal system. I talked to you about material. So, if you think about the material design, is much more sophisticated than any material that you have seen in any sophisticated artificial hand. And the ecological niche, the treadmill in the case of a puppet, in the case of Simon ants, and also real ant studied by Olk Kruse, the terrain where it works. And this is a question, it may be for next time, because today we have, that you can think offline about it. and maybe give your answer to, in this diagram, what are the most, which is the most important part, and what's, if you want, the less and the absolute, very, very, very least important. So